Kevin, welcome to SQL Friday. The stage is all yours.
All right, thank you very much. And I'll start sharing the screen. And note that the most important part of the title is the secret Back to the Future reference. Where we're going, we don't need servers. So this is the Serverless SQL Pool in Azure Synapse Analytics. Hello, everybody. My name is Kevin Feasel. I'm a Microsoft Data Platform MVP out of Durham, North Carolina, where I have a blog called Curated SQL. The idea of Curated SQL is that I want to try to find and link to 5 to 10 interesting resources per day on topics all across the data platform space. So it's curatedsql.com. What I want to do in today's talk is give you an understanding of what the Azure Synapse Analytics Serverless SQL Pool is. We're going to see how we pull some data into it and query data from it, because it's kind of important when you're, pooling data, and get a feeling for how much all of this is going to cost. So I'll start with an overview. And by the way, if you have any questions, please do feel free. Put them in chat at any point in time. I'm watching it right now like a hawk. So Azure Synapse Analytics, this is Microsoft's platform for modern data warehousing. And there are several components to it. Dedicated SQL pools used to be called Azure SQL Data Warehouse. Spark pools run Apache Spark. Serverless SQL Pool is what we're going to talk about today. Data Explorer pools exist, and they're in preview right now. So I don't want to go too far into it, but they're an interesting idea for log analytics and for time series analytics. It may make the concept of future talk, but not today. Briefly, or actually less briefly, since I just did the briefly version, dedicated SQL pools are intended for data warehousing. This is answering known business problems and works extremely well with the Kimball approach to fact and dimensional warehousing. If your total data size is at least 1 terabyte, that's kind of the you must be this tall to ride the ride sign for dedicated SQL pools. Do you need a terabyte before you can use one? No, I mean, they're not going to prevent you from using it, but the idea is you're probably wasting money by using it at sizes under a terabyte. Not always, but probably. Also, you'll want to have fact tables with at least, at the very, very minimum, 1 million rows for a fact table. Ideally, 60 million rows for a fact table. And ideally, a much larger number, say if you partition yearly and you have 4 years worth of data, at least 240 million. So their rule of thumb is if you've got one fact table with 1 billion rows, you're probably a good candidate for a dedicated SQL pool. Your dimension tables, small, but probably fairly wide, and users are working off of known business problems. I have these regulatory reports I need to run. I have these quarterly reports that finance needs. I have these regular customer reports. The importance here is regular. You can understand, anticipate, and design for what people want to use. Spark pools in Azure Synapse Analytics are primarily for 2 key purposes. Number 1 is performing data transformation operations using Apache Spark. Spark has a lot of transformation capabilities that are very difficult or impossible to do in T-SQL. And the other use is for machine learning operations. Used to be that Azure ML and Synapse Analytics Spark pools both would do Spark-based processing, but in Azure ML, there used to be a curated environment for Spark MML. It's gone. Hope maybe it comes back someday, but as of right now, there isn't one. If you want to use Spark-based machine learning, it's a lot easier to use Synapse Analytics Spark pools instead of trying to shoehorn it into Azure ML, where you have to load all the libraries and do all the configuration. So now let's talk serverless SQL pools, and I'm going to contrast that with the dedicated SQL pool to give you a better understanding of the two. Serverless SQL pool. The serverless SQL pool does not store data, which you may think, a database that doesn't store data, that doesn't seem very useful. But what it does is that it reads data from your data lake and exposes it in T-SQL format. So you can query data directly from the lake. You don't have some intermediary. They also don't require specific infrastructure that you set up. There are no resource reservations, and there are no upfront costs. Meaning, I could have a serverless SQL pool running for a year, and if I don't use it, I don't pay for it. This is by contrast to a dedicated SQL pool where I set it up. I actually have one that I just set up a few minutes ago, and I'm going to be paying for it until I pause the thing, delete the thing, or run out of money. The pricing model for serverless SQL pools is $5 per terabyte of data processed. We'll talk what terabyte of data processed means in a bit. And those prices may actually be different based on the region. But let's talk key use cases about the serverless SQL pool. Data spelunking, this is my favorite one. Ad hoc data analysis. We mentioned the dedicated SQL pool is extremely good at fixed business queries or fixed classes of business query. But if you've worked with on-premises data warehouses or with dedicated SQL pools, there's a problem that comes in where, let's say I'm a researcher and I say, I want to find the relationship between this and this. I saw a blog post recently that was talking about confounders, and it was the amount of chocolate consumption versus the number of Nobel Prizes, and by country per capita. And there's a definite relationship there, which says there's a chocolate consumption crisis in many countries. Switzerland has no problem. But suppose that I want to do this type of analysis because I don't understand the concept of confounding variables. I may talk to the warehousing team and say, hey, I need some chocolate consumption data brought into the warehouse. And the warehouse team says, okay, it's going to take you 2 sprints to get that in because we need 1 sprint to design it and then 1 sprint to design and to get the data, and then another sprint to set up the ETL pipelines, to add the new columns, to load the data, to backload the data, to test everything, make sure nothing else breaks. And 2 months later, I get that data, and then I run the analysis, and it finds out that, oh, yeah, there's actually an underlying variable that explains both of these. This is a really bad analysis. All right, well, I'm not going to use this. And from hereafter, that chocolate data is going to live in your data warehouse forever. Nobody's ever going to touch it again. I'm not going to tell you that, well, the research was that it's not very useful, because I want something from you in the future. And if I tell you that now, next time you're going to be like, well, do you really want it? So that type of use case where it can take months to get data in, if I really just had the data available in a file someplace that I could easily bring in, write some queries, find out that not very useful, and then throw it away. This is what a serverless SQL pool is extremely good at. Taking this to the next level, you could actually get to data warehousing in the serverless SQL pool, where if I don't have a terabyte of data, if I don't have 1 billion rows in my fact table, if I have just 5 gigabytes of data, and I have sporadic usage throughout the day, so I can't pause it and save a lot of money, a serverless SQL pool might actually make sense for a logical data warehouse where I can write queries against that warehouse and not have any problem with very expensive dedicated SQL pools. Data Explorer pools, like I mentioned, log analytics, and some interesting time series analysis using the Custo query language. So that's what Synapse Analytics can do. Let's briefly create a pool, and then we'll start querying data. So when you create a workspace, it creates for you a serverless SQL pool called built-in. And I'll say you cannot create another one. If you select new SQL pool, actually it doesn't even say new anymore. It says new dedicated SQL pool. So this will only allow you to create those dedicated pools. Can't delete your serverless SQL pool on accident or on purpose. You get one and only one, but you don't really need a second one because, again, you're not storing data there. So let's see how we might query this thing. And for our scenario, it is 100 years in the future. We are working for the Martian Agricultural Data Collection and Ownership Combine. Our job, we're collecting sensor data from a lot of agricultural plots across Mars, which we have, of course, terraformed. And we're trying to understand which plots of land are best suited for specific crops. We've collected quite a bit of IoT sensor data, and the management wants us to build some systems to allow rapid access of this data for the kinds of spelunking I was talking about without having to wait 2 sprints for our warehousing team to get it in place. So we're going to use Serverless SQL Pools for the job. Now, the Serverless SQL Pool is T-SQL. You write regular T-SQL queries, mostly. I say mostly because this product does not support the entirety of the T-SQL namespace. For example, you cannot insert data, update data, delete data, merge data, truncate tables. You don't really need to do any of that because you don't have the data in your database. It's all externally accessed and it's all read-only. So if it's read-only and we can't insert data, how do we insert data into the thing so that we can read it? The answer is you load it from somewhere else. You load it from Azure Data Lake Storage as a good example. Every workspace that you create for Azure Synapse Analytics will have an associated Data Lake Storage account. And you can add additional Data Lake Storage accounts in order to tie in with other resources. And then you can use the open rowset command to read data from files or folders. So I have here an example of open rowset. So from open rowset, we'll bulk load a file. This is the ABFSS format. This is just one way of accessing our data lake. And I have folders, Mars Farming Raw, Airability Score, and then I have a file, Airability Score 1.txt. This is a CSV. Technically, it's a semicolon delimited file. So that's a quick shout out for the Germans in the audience. And we're going to say the first row is number 1. We don't have any headers in there. We just have raw data. We can define the schema from that CSV. So I could say there are 3 columns in there. The first is a plot ID. Then there's a report date time. Finally, there's an Airability Score. And we'll be able to call this Airability. We'll get a result set back, Airability, and be able to query it. Open rowset supports CSVs as well as other delimited files. I chose semicolon delimited sets just to show you it's not just commas. It'll support Parquet. You can load JSON, and now there is support for Delta Lake. That's fairly recent. Let's talk Delta Lake. I will talk about Parquet in a moment, but first let's talk Delta Lake. The Delta Lake format was originally created by Databricks and was then gifted to the Linux Foundation for promulgation into the broader open source community. Delta Lake allows you to write serializable transactions in a data lake, which means I could begin transaction, write something, and commit or roll back that transaction, and it'll actually work. You can also perform what they call time travel. And in the SQL Server world, our best analog is temporal tables. So if I have a temporal table, I can write a query and ask, how did this data look as of this date and time? They also use schema enforcement via the Parquet file format. So I've talked Parquet now. If you're not familiar with this format, this is a columnar file format. So data is stored in columns as opposed to rows. There are a couple of benefits to this. Number 1, it is extremely efficient for fact-like data. Think about clustered column store indexes in SQL Server. And if you're familiar with the best practices for those, you use them on fact tables that have a lot of numeric values that don't have text values. And you get incredible compression because typically within a column, there is much less variety in terms of what your data values are versus in a row. In a row, you'll have maybe a dozen or 2 dozen different columns that have different ranges, even if they're all numeric. Some may be 0 to 10, some may be negative a million to 28 billion. Within a column, though, that 0 to 10 means, well, you only have 10 possible values, and you can compress that down extremely well. Parquet also allows you to collect metadata about that table, schema information, types of stuff that you can't get out of CSVs natively. You can store that schema information inside the file, and there's also header information that tells you how many rows there are. It tells you how many columns and their data types, and gives you some quick idea of the cardinality of columns. So this is overall pretty good file format, especially when you are dealing with very large amounts of data that has a fair bit of duplication. The last big thing is if I perform aggregation style queries, select the sum of values from this column out of this table, Parquet works extremely well because you can pull one column. You don't necessarily need to pull in the entire file with all the rows. You just need the one column. And Delta Lake also does give you insert, update, delete, and merge, but not in the serverless SQL pool. Serverless SQL pool, still read only. If you want to do this work, you do it via Spark SQL. Let's take a quick demo and pop into, actually, I'm already in here in my Synapse workspace. So I've got a workspace here already created, and maybe I'll bump this up one more notch. Let's run a couple queries. This is telling me that I need to create a database if one does not exist already. So I've got one here, but this is, I need to use the built-in. I just created this dedicated SQL pool this morning, and I'm so used to go check the dedicated SQL pool because you don't want to run in the serverless pool. And then I remembered, wait, I'm talking about the serverless pool today. So I've got a database Mars farming already. If you don't have a database Mars farming, you can create one pretty easily. But I've got it, so let's use it. And then from Open Row Set, we're going to query my BDA data lake, the Synapse container, the Mars Farming raw folder, Airability Score, and get the first file. You may ask, how do I know that that thing exists? Well, if I navigate over to data, I can select linked and find my linked resources. I've got a data lake right here. Let's pop it open, and we see a Synapse container, inside of which I've got some data. So I have raw data, about 7 different measures. And if I take a quick peek at that Airability Score in here, I can preview it, and you see that it is semicolon separated data with no header. If I want to get that file, I could go to Properties, copy the path for that, and then paste it into my script. If, by the way, you need to create a serverless pool database, then you can create a SQL database in here, serverless, call it Mars Farming. So just in case you haven't created one already for some reason, let's run this script. Let's make sure that it works as I claim it does. And after that, we'll get rolling with a bunch of other stuff. So this is going to take a few seconds to wake up in the morning, just like the rest of us. But we've got this data. So plot ID, report date, time, Airability Score runs just about like you would expect it to. All right. So, you know what? Let's do some more demos. I don't want to go back to slides just yet. Let's do more demos. Let's talk about distinct years. So we have Open Row Set, and instead of selecting star, I can operate on Airability as though it were a regular result set. So if I run this, it's going to change the context of Mars Farming and run, and I get my years 2116 through 2120. That's what we've got our data. So we haven't updated it for 2121 just yet. I'm waiting for SQL Server 2122 to come out. Let's find out what was the best Airability Score of the year 2117. So again, I can run aggregations. Basically, once I call this thing Airability, it becomes a virtual table. It behaves like a table would. So I have the wide variety of aggregations of operations off of it that I would expect to have. And I would also expect it to be a little faster, but I have noted that a lot of products tend to be very shy when they know people are watching. So right now it's just very shy and hiding, but normally it's not going to take 29 seconds. Max Airability Score 1.03. What if I want to do JSON files? Yeah, I mentioned you can do Parquet, you can do JSON, you can do CSV. Actually, over here, this was Parquet. So I ran through this example, didn't even tell you what the data format was, but it's in a curated folder, Airability Score by the year. This is all of the months. This is all of the Parquet files in there. Let's take a quick look at that. So I pop up to curated. So I have my measures here. And within here, I've got this built out by year, by month, and there's just a bunch of Parquet files that are very small. That's not the most efficient, but it was easy to create. The other files that I have are in metadata, and they're in JSON format. However, when I say they're in JSON format, let me show you what the format looks like. This is a pain point of mine. This is a JSON object. I can tell it's a JSON object because it has a curly brace and a curly brace, and then it has key value pairs with some attribute name and some value. That is a perfectly legal JSON object. No problems at all with this. Now, I have a second JSON object, also perfectly legal. Normally, when I have more than one JSON object that I am putting together, I am going to use a JSON array or a list. To create such an array or list, I use a bracket, a square bracket, and I put commas between these because that is what is required in the JSON format. However, if you do this, the Serverless SQL pool will not read your data. It will only read JSON data structured exactly like this, where it is one object per row with a new line separating them. I don't like that at all because this is not standard JSON. You have to modify your parser in order to get it not to write out a list as, legal JSON. But that is the constraint we work under. And therefore, when I read this JSON, it will work. And you'll notice there is no JSON formatter. It's actually using the CSV formatter, which is why there's this weird rule. When you put in a field terminator and field quota of 0x0b, that is telling the formatter, this is actually a JSON file. We don't really have terminators and quotes that are special. So just treat it like it's JSON and read that outcome. And then I can get a document, which is varchar max. So it brings in the entire JSON object as one varchar max column. And then I can use JSON value to split out the individual values. So when I run this, I get my doc, which is the entire object, and then my individual values. So it works, but it requires some finagling, particularly with your data. Here's another example where I'm looking at different plots on Mars, and I have my plot ID, owner, city, and the size in acres. When you go to Mars, you get 40 acres and 1 space mule. So we have our data in here, and we can read it using open row set. Next, we're going to try to make this a little more useful with Polybase. Azure Synapse Analytics extends this technology that Microsoft has called Polybase. Polybase is a really cool technology, allows you to perform data virtualization, especially on premises in SQL Server 2019. I have an entire talk on Polybase. If you want to go check it out, I'll drop a link in the chat for later on. I have an entire book on Polybase if you really want to dive into it. But what we need to know for today for this serverless SQL pool is there are 3 types of external data object: sources, formats, and tables. An external data source is a pointer. Your data is over here. It is a remote location for the data itself because the data doesn't actually live in the serverless SQL pool. And when I say migrate, I mean actually permanently move. When you query the data, yes, that data is read in by the engine. It is processed by the engine. It may even live in a temp table in the engine. But then after your query is done, If there is a temp table, that temp table goes away. As far as we're concerned, the data never really lived in SQL Server or in Synapse Analytics, the serverless SQL pool. I want to create an external data source. I have a location and a credential. So that location is going to be perhaps a data lake, and we have a credential. So I'm going to have to create one of those. This uses SAS tokens for credentials, and I create a database scoped credential. Maybe I call it SAS token right. The identity is the string literal shared access signature, and the secret is a SAS token. By the way, if you try to do this on-premises SQL Server and SQL Server 2019, will not work. You'll need a different process for connecting to Azure Blob Storage. File formats are going to tell you what type of file. Is this CSV? Is it ORC? Is it Parquet? If you're not familiar with ORC, some people call it ORC. Those people are taking the fun out of life. And this is a competitive file format with Parquet. It is another column store style file format. But in the Hadoop world, Parquet was popularized by Cloudera. ORC was popularized by Hortonworks. And now that they've smashed together, Parquet has kind of taken over as dominant. So we create a file format, maybe a CSV file format, and I specify that this is a delimited text format, and I'll use commas to separate values. I'll use strings as delimiters, and encode as UTF-8 or UTF-16. For Parquet, I have a lot less to do because all of that schema and structure is defined within the file itself. So all I need to do is tell it that your format type is Parquet, and if we have compression. So there are two codecs for compression. There's Snappy and gzip. One of them is slightly faster, but requires more CPU. The other one is it's slightly faster, but requires more space on disk. So faster meaning less CPU, more space. The other one, less space on disk, more CPU. But the differences aren't really that big. Not in my experience, at least. So I'm just going to elide over them. External tables. Once you've defined the data source, you've defined the file format, you're going to create a table shaped off of that data source using that file format. This is going to require structured data. So your data lake may have a lot of unstructured data. Well, when you query something in SQL Server or any sort of SQL Server related product, including Azure Synapse Analytics Serverless SQL Pool, you need structure. Here I can create an external table. I could say, create external table, so one extra word, have my columns, plot ID, date, time, and Airability. And those parts were pretty normal except for that one extra word. Here's where things get a little weird if you're used to creating tables. Because I need to specify the data source. So where is that data actually located? Then specifically, what folder is it located in? Or what file name is it in your structure? So my location, Airability Score 2120.01 on that curated data store using Parquet format. And this will allow us to query this external table using our regular T-SQL knowledge. You can also combine open row set with Polybase's create external table as select syntax. So that's CETAS. In the Synapse world, there's CTAS, create table as select, something I'd love to have on premises. And then there's create external table as select. So I can do some really cool things with open row set and create external tables. What this is doing is it's saying create an external table, Airability 2116.01. It's going to live on my curated data store in a location, Airability Score 2116.01 in Parquet file format. Importantly, this folder does not exist yet. I'm going to create it through the process of selecting data. This is the one exception to everything is read-only in Serverless SQL Pool. So I'm querying from Open Row Set, saying, go read all of the text files that were in my raw data. the text files were all of the data for each sensor over a 5-year period. So I had to reshape the data and write it out by month across all sensors. I formatted CSV, it's semicolon delimited. We've seen examples of this already. And I specify the file format. So I'd like to have that format in my Parquet files, except I only want the year of 2116 and the month of 1. And if I run this, then what'll happen is it's going to create a bunch of Parquet files in the curated folder underneath Airability Score 211601. And that's exactly what I did to load all of this data. So let's take a quick look at the demo. If you are interested in learning more about how I loaded the data, I do have load scripts in here which show you all of those steps. So creating external objects. In order to create external objects, we need first to create a master key. I already have a master key, so this should be pretty fast. Then we need a database scope credential called SAS token write. And you can see I've already created one. If I had not created one, I would need to create one. And there are a couple of easy ways to do it. Probably the easiest is to use either Azure Storage Explorer or go to the Azure portal, and there is an option to generate a SAS token there. You can also generate them from the command line, AZCLI, or even Azure PowerShell. I need to create a data source called Mars Farming Curated. So it's going to live in my data lake in this Mars Farming Curated and use that SAS token for any data access. And I've already created this, so this script should be fast. Parquet file format. All of my data that I'm going to read will be from the curated section of my data lake where everything's in Parquet format. And then once I'm there, I am going to check. I think I actually, it looks like I do already have this table. But even if I didn't, I would create it here using create external table with location of Airability Score, data source of curated file format of Parquet. I could just drop this and recreate it. But remember, this is essentially a pointer to another source. So there's no data, there's no real benefit from dropping and recreating, except to show you I can. If I query this data, I write just regular T-SQL, it reads from the data lake, and as far as average users are concerned, it's in a different folder called external tables, not tables, but otherwise this is just a table. I can write my queries where I have any filters that I want. I can join to other tables. I can do pretty much everything that you would expect to do with the SQL language, as long as it means creating or retrieving data, not inserting, update, or modifying. Here's an example of my creating a new folder, Airability Score, in the curated for one particular month. I'm not going to run this because it does take about 10 minutes to run. So I'd be dancing around for quite a while. We did talk through what it looks like though, and it works out pretty well. This is probably my favorite use case for the serverless SQL pool, spelunking data analysis. Great for ad hoc data exploration because a couple of reasons. One is I don't have to put in all of that cost of building out a proper warehouse. But the other one is I get file path related searches. So I can use OpenRowSet to load data from a single file. We saw an example of that earlier, where I grabbed from Airability Score 1.txt. I can also use wildcards to grab multiple files, which I showed you on the slide. If I say Airability Score /star, everything within Airability Score, but not subfolders. So that's an interesting thing with a serverless SQL pool. You actually don't select subfolders. It's not recursive. So this will be everything within that folder, but no subfolders. This will be all files that start with Airability Score and some character. Technically, the Yeah, actually with the underscore, yes, this is not a like statement. So Airability Score underscore and then whatever, and end with the format dot text. Here, Airability Score underscore one dot whatever. Perhaps we had some that were dot txt, some that were dot csv, whatever the output may be of that format. As long as they're all the same structure, this will work fine. If you have things that are different structures, you have different file formats, maybe you've got some Parquet, some CSV, you're going to have to be a little more specific in your wildcard searches. So I can also use the file path and file name functions to get details on a file. If I say, load all the files in January of 2120 in the Parquet format for Airability, and then I could get .file name as the file name. I could get the count of number of rows and group it by file name. What I get back is every file and how many rows there were in that file. And you see the query only took about 2 seconds in this screenshot because it doesn't have to read the data itself. All it has to read is the metadata, the header information that said there are 1,089,216 rows in this file. And it says, cool, I'm done. But what if I have more than one file path or wildcard in my file path? So I could say Airability Score star for the year, star for the month, star for the file name. And I can reference using a numeric value starting from 1, however many wildcards I have, I can reference all of those as separate values. And so I could select file path 1 is the year, file path 2 is the month, and get the number of rows, group it by those two, and then it gives me year, month, number of rows. And again, this is a fast query because it doesn't have to read all of the data. It's just aggregating across the metadata. It's using the year and the month as attributes to perform that filtering. Going a little further, I can use that in a where clause. I could say where the file name is like C, or where the file path, the year is 2117. And it will pull only the relevant records. So these are the months that have Parquet files that start with C and only the files that start with the letter C. And then I can export that data to a variety of different formats, CSV, JSON, XML. I could download that, use it myself. I can even create some basic charting off of that information. So I see the number of acres and based off of the plot ID and get a rough idea that, yeah, everybody's within about that 40-acre range. So let's look at this in a couple of demos. Using file path, I have my file name, and let's run this query. We're going to query everything in the year 2120 January, and this took 1 second. So getting all of these records really fast. Not only really fast, but also really cheap, which we'll get to in a moment. If I want year, month, and file name, so file path, file name, I get all of the Parquet files for all of the years and query this. This one, because I just complimented it on how speedy it is, it's going to be really slow. It's still just reading metadata, but I apparently angered it by being nice. Teaches me to be nice to something. There we go. Year, month, file name, and number of rows. I can ditch the file name and just include year, month, and number of rows because I've got, what is this, 2,300 rows. So let's run just year, month, number of rows. And 57 rows remaining. So year, month, number of rows, everything's looking good. I can filter on specific file names. So within Parquet, say where file name is like C. Actually, let's Let's change it. Make it D. All of those file names are unique identifiers. Just because that's the way that they were written out when loading from Polybase using CETAS. Takes a hot minute, but it'll finish up, and it will finish up. Very shy today. So actually, let me take this moment and address that. Yeah, you will have some variance in query performance time with serverless SQL Pool. That is kind of a downside to it because you don't have much control. And if you want to make queries faster, it's not like a dedicated pool where I can just kick up a number and make things faster immediately. So it's sort of deal with what you get. Don't use this for queries that you need sub-second performance. This is for ad hoc querying, not for transactional processing. So here are the years that had Ds, and if I change it back to C, I would get the same results we saw earlier. I'll skip visualization for the sake of time. Logical data warehousing. So historically, we've built these physical data warehouses. I have on-premises or frankly in the cloud. I'll have some dedicated warehouse, like a dedicated SQL pool. I'll pull data from a lot of sources, have an ETL or ELT process to load the warehouse, and then maybe I break out that warehouse from there using something like analysis services, or bring it into Power BI, bring it into reporting tools, and expose the data. There's a lot of groundwork, a lot of framework in there. For this cloud era, there's a movement toward a concept called the lake house, the data lake house. Databricks coined this term, and the basic idea is this tendency over time to try to move things further and further out from structured planned processes. So in your late 80s, you had all of your data sources that you would ETL into your data marts for reporting. With the data lake, we dump a whole bunch of data up in here, and then we do a lot of ETL work to load those data marts, like in the 80s. We also may have some real-time data that we're loading up, maybe streaming it into Power BI. And also we have data scientists and teams like mine. I run a predictive analytics team, and we have our own data prep processes that we need for the work that we're doing. The concept of the lake house is that you still have that data lake. All of your data lives there, but instead of having ETL and data prep processes external from the lake processing itself gives you the data that you need for all of your different work. I will tell you that as of today, the lake house is not really a viable option for most companies. I think it's an interesting concept. Give it 3 years, 4 years, and I think they'll be in a much better place. But as you saw just from doing some basic serverless SQL pool queries, there can be a wide range in performance differences to the point where if I'm relying on this for critical business needs, I don't think the performance is there. But for smaller organizations or for cases where it's a automated report, this actually is a pretty good case for logical data warehousing. I can create external tables using Polybase and query those in my serverless SQL pool. So let's take a quick look at what that looks like. Here's Airability Score. I'm going to create a view, dbo.airability score, from Open Row Set, and all Parquet files across the board. So I showed you how to do it in Polybase. I'm also going to show you how to do it in Open Row Set, because both of the approaches will work. Here, these are views. We're going to run each one. There we go. Those were all Parquet files. This one is JSON. Create a view called dbo.plot from JSON. And then I can query the data. So let's Select the top 5 from dbo.waterscore. Make sure that the water score is there, and it is. And perhaps I want to look at what did each plot look like as of a particular time, 2118, March 15th at 8 a.m., the Ides of March 2118. And I have all of these different measures from plot joined to all of my different sensor information. But if I want this to perform well, I'm going to have to add some filters. So for each of these, I've added year and month. And if I show you a water score, file path 1 is year, file path 2 is month. I don't really care about the file name. I really care about the data in full month format. So I have to add in all of these filters. I would love for this to be enough between that and these joins to be enough to say, well, based on the way that we're filtering, I only need to look at data in the year 2118 in the month March, and therefore only pull data from that folder. If I don't include the filters, this is going to include all files. It's going to take a long time. It's going to scan for a while and will be just a nightmare for everybody. By including all of these filters on each of the different sensor measures, we're going to make this a much more tractable query so that it returns generally returns in about this much time, but today it's not returning in that much time. Oh, see, I just had to complain about it, then it would finish. But I get my city and size and these measures, all of these different measures across a bunch of different tables, all brought together for 5,000 records. I actually only scanned 234 megabytes of data to do that. That's not bad. I do have a little section on security, very briefly, because I want to take some time and talk about money. There are several options available to secure data in a serverless SQL pool, but not as many as you would have on premises or in a dedicated SQL pool because the data is not here. So you can control the underlying data by generating SAS tokens. Here is me creating a SAS token out of a storage account container. So I'm in the storage account, I select the container, I right-click, generate SAS. That will allow you to generate a SAS token that gives you access for read, for write, for list, for other privileges. Well, you can specify for this SAS token, this is the write token, you'll have the ability to write for CETAS, but maybe for other ones, you just get the ability to list and read. And you can control which users will get access to which tokens by creating roles and assigning people to the roles, and then by creating different views and granting people access to those views that use the different tokens. Serverless SQL Pool obviously allows you to create roles, and I can add members to roles, so that way I don't have to do a lot of user-based access. I can grant specific permissions on, say, objects like my view to analysts, so that way you could separate out these people will get these rights to these folders and have a little bit more granularity in your I guess I'll call it structured ad hoc querying. So select on DBO to analysts, references on SAS token write to analysts. That way, if you grant references on the credential, analysts will be able to use that credential in their own queries. For bulk operations, if you want to use OpenRowSet, you do have to grant administer database bulk operations. On-prem, that sounds kind of scary. Up here, literally the only thing they can do is OpenRowSet. They're not going to bulk load data. You can't insert data. Grant control is a strong permission. So I wouldn't grant control to just everybody. It allows you to set up permissions, create or destroy external tables and views, and query data via OpenRowSet. Querying data via OpenRowSet, like I mentioned, you just need grant administer bulk data or database bulk operations. Control will let you do a lot more. And You might give this to some power users, but realize there is only one serverless SQL pool, so you're not going to be able to segregate people out, which means the more people you grant control to, the more likely someone's going to stomp on someone else's work on accident. There is no row level security in serverless SQL pool itself. There is the ability to kind of fake it using table valued functions. So I have here a view, Airability, that queries select star from open row set, and it grabs all the Parquet data. And I could say where my username is whatever, or I'm in a role, North Armstrong Analysts, and the city name is North Armstrong, or I'm in a role and have it in a city, or I'm in a role and a city. And you do this for each of those cases. For a situation where you've got 5 or 6 cases, it's annoying but tractable. For 500 or 1,000 cases, this gets a little crazy. This is why I say there is no real row level security. You're just faking it. Now, you could put this into a table valued function and get something that looks more like the way that you would work with the row level security in a dedicated SQL pool. And so I create or alter my function that takes in a city name, and I select the condition equals 1 if you match that condition. And then take Airability and cross-apply city analyst. So unlike dedicated SQL pool row level security, I do need to do that cross-apply operation. But you could wrap that in a view, and then people query the view, and we'll have that row level security built in. Last thing, gotta talk about money. How much is this going to cost me? Because dedicated SQL pools cost me a lot of money. Spark pools might cost me a lot of money. Serverless pool, I told you, $5 per terabyte processed. But what does that really mean? Well, to process data, you read it, you read the metadata, you read or write the data to intermediate storage, like if you have a spool. So your lazy spools cost you money. Not only do they slow you down, but now they cost you money. Makes me hate lazy spools even more. Writing the temp tables costs you money. Reading from temp tables costs you money. You write the data to storage via CTAS, you're going to pay for that. You transfer the data between nodes, between the compute nodes, you're going to pay for that. You write it out to the end user, you pay for that, which means select star from giant view that has 100 million rows, and somebody runs that query and lets it run for all day. You're going to pay several times for that data processing. You're going to pay to read it, to work with it, to write it. Every query has a minimum 10 megabytes. So try to avoid transactional processing style, select one row, select one row, select one row. Avoid an enormous number of very tiny data files, because each file also involves, I'm reading this is 10 megabytes to read that 100-byte file. So how do we save some money? Well, scan the minimum amount of data. Use the right file format. Parquet will usually be superior to CSV in this case because Parquet compresses down to smaller sizes, includes column metadata, so I just read the metadata header for certain types of queries and save money there, and I only read the columns that I need. So if I have a wide table with a lot of columns, if I only read these 2, I'm only paying for those 2. But there is a cost to Parquet, and that cost is the results are returned back uncompressed. So if it's, let's say I read 1 terabyte of Parquet data, and my compression ratio is 5:1, and my user queries select star and returns back 5 terabytes worth of data to Management Studio, and amazingly Management Studio doesn't crash. You will be charged for 1 terabyte of compressed data, 5 terabytes of uncompressed data. That is 6 terabytes of data. That is a $30 query by somebody who just select starred and went to lunch. If you aggregate that query, you still pay potentially for that terabyte, that 1 terabyte there. But if I group it so that I only return back maybe 1 gigabyte, I'm paying $5 at that point instead of $30. So bad queries will literally cost you money. You can filter on file name, on file path to narrow down what you want to read and return. I showed you an example where I had those filters on a.year equals 2116 and a.month equals 3 or whatever. This is going to save you money because you'll only read that folder instead of all of the folders for all of the years. It'll also make your queries faster. So better performance, less money. That's kind of a win-win. If you do certain calculations quite often, it may make sense to use CETAS to pre-generate your results, especially if they're fairly stable. So let's say that I'm reading annual data for the last 7 years, and I only read it at the end of the year once all the books have closed. I may pre-calculate my annual aggregations so that I have one row per year instead of having to recreate that every time I run the report, because then I only pay for that processing charge once, and then I pay for 10 megabytes for my one row per year. So that can be a massive performance difference, much better performance, and also much cheaper. Sometimes it'll the serverless SQL pool will pre-process some data in CSV format. So if I have a large CSV file and I only need to read a few rows, like top 10, it may read more than just the first 10 rows. It might read a chunk of 50 or 100 rows. So you may be paying fractions of a cent more as a result of what you're doing. If you don't want to have that problem, store the data in Parquet and read entire files rather than parts of a file. So structure your data so that it's in files that you'll want to read as a whole, but maybe not necessarily that much larger. So you may need to reshape files as a result of this if you're really looking to optimize costs. If you want to figure out how much money you've spent, sys.dm external data processed is the way that we're going to see it. So as we wrap up this talk, let me show you how much money that all of this has cost me. Over the course of the day, I've paid less than 1 cent. So to show you all of this, I've processed 700 megabytes of data at 0 cents. Can't get too much cheaper than that. Obviously, with larger queries, that money can add up fast. If you have hundreds of terabytes of data, you have to be a lot more careful in how you write the queries, because bad queries will cost you a lot of money. As we wrap things up, this has been a look at the serverless SQL pool in Azure Synapse Analytics. It's kind of a cousin in the SQL Server world. There's a lot that's different from it versus on-premises SQL Server, other things you have to think about. But I think that your experience with SQL Server brings a lot to the table with a serverless pool. And if you understand some of the financing and some of the processing differences, it becomes a very useful tool. If you do want to learn more about this, I have the slides, I have the demos, I have links to additional resources at csmore.info/on/serverless. If you have any follow-up questions after this, please do feel free to hit me up via email. I am also occasionally on Twitter. And with that, if there are any questions, I'm happy to take them. Otherwise, I want to say thank you so much for attending this SQL Friday, and I appreciate your time.
Thank you for coming, Kevin. I have one question, which is about the sorry about my voice. I've had a cold this week. The wildcard searches for folder. Do you know if there are any plans to implement the ** way to do the recursive, or do we just have to know the number of subdirectories to search in?
Yeah, so that is, as far as I'm aware, I don't know of anything that'll introduce recursion. It's also a little bit of a difference in behavior versus what we're used to with on-premises SQL Server, where with Polybase, the stars were recursive. So you would see everything in a directory as well as all subdirectories. But with the serverless pool, I guess they've made the explicit decision that if you're within a directory, you're only interested in that directory and not the subdirectories. And I think a big part of that is for cost, so that you don't accidentally bring in stuff you don't intend.
Yeah, I get it. Do you know how widely used this is right now? I mean, how many customers worldwide are actually using it in their day-to-day reporting and analysis?
Short answer, no. Unfortunately, I don't have any of those details. I can estimate that it's becoming more popular. Over the last year or so, there's been a huge push from Microsoft to get people to adopt Azure Synapse Analytics. And in working with people who are at Microsoft, they've let slip some information that a lot of customers do tend to be interested in the serverless pools and make it really that's probably more interesting to them than the dedicated SQL pools.
No, I mean, for myself, I worked with so highly regulated clients who are still trying to get all the legal terms together to even use any Azure services. So I'm kind of stuck on premise with the data. Some services like CDN for websites and so on might go to the cloud, but mostly it's on premise, and we have to live with the data centers. So.
Yeah, and there are going to be a lot of companies that will probably be that way for quite some time, unfortunately or fortunately. I mean, our data centers are on premises where I work, and I don't really want that to change because of performance requirements.
Yeah, and I guess that's what they try to meet with big data clusters and stuff like that to be able to get most of these things on premise as well, which is, I mean, it's in a way we will see a hybrid world for quite some time, I guess.
Oh yeah, definitely.
We'll see when we have farms on Mars where the data centers are. That's going to be interesting.
They're probably going to be on Mars because you figure that east US, that's a 7-minute wait.
Yeah, so I guess then there will be the Martian region. So, yeah.
Yep. Now that hard line to connect the two, that's going to get real awkward.
True. Yeah, it's hard to do. Have another region as the DR. So. Cool. Let's see if we have any questions. We have people like you, Kevin. I did as well. So I agree. Thanks for your presentation, and I look forward to I don't know what we're going to call it, in-person world. I saw a discussion yesterday. Should we call it in person, or should we just say it's not virtual anymore? So when we go back to being in person, I don't know. Do you have any plans, by the way, for traveling and actually meeting people face to face?
I've actually done a couple of them in Orlando, Florida. So there was the SQL Saturday in Orlando. It was the only US SQL Saturday that was in person this year. And then Live 360 was down in Orlando. Tomorrow, I'm packing up my bags going to Las Vegas for Dev Intersection.
All right. So that's happening again. Cool. Las Vegas. I was attending Kevin Klein's session about the history of PaaS on the summit 2019, and he said that they had been thinking about doing PaaS summit in Las Vegas, but they figured so many companies would just say no to their employees going to Las Vegas, especially for the Europeans. It would be like, no, Seattle might be okay, but going to Las Vegas, that's not going to be a real conference. It's just going to be a lot of fun. So we're not going to pay for that.
Right. Well, I mean, the funny thing is that there are a lot of extremely large conferences that happen in Las Vegas. They have enormous conference centers like CES, the Consumer Electronics Exposition. Yeah. It is enormous. It basically takes over most of downtown Las Vegas, and has to be 80,000 people in a good year.
That's cool. I heard about the planning for some kind of AWS conference where they were hosting it in 2 different conference centers, and then figured, should people really have to go down and walk on the street to get? No, let's build a bridge between the 2 conference centers for the conference. So it's another scale than I'm used to.
Yeah.
I mean, for me, I think past summit was pretty big, but that's
right.
nothing in comparison.
Yep.
All right. I'm going to go back to, unfortunately, paid work. I guess we all have to some days. Let's just see what Gabor is writing. Gabor is an old colleague of mine, actually. Long time no seen, Gabor. We'll have to go back to lunches. Oh, and for myself, I'm stuck in my own office in my hometown. And I've been to Stockholm, where my clients are, maybe 3 times in 2 years. Thanks, Kevin. Nice topic and perfect presentation. Yeah, I agree. Except, I mean, of course, devil is in the demos, as always. If you expect it to take 1 second, it's going to take a minute.
Yeah, that happens, and there is some variance in there, and that's really I think the trickiest part with serverless SQL pool, that I can't guarantee you this is going to take X amount of time. So it really has to be, this is the type of query that I can fire and forget and just wait for it to finish.
Yeah. I had the same thing on my first SQL Saturday presentation. Speaking of SQL Saturdays, if you guys didn't know, I think Kevin has the world record in number of SQL Saturdays presented at. You're well over 100, right?
I am over 100. I think there are a couple of other people who are over 100. I don't know if I'm number 1, but since in the past 5 years or 6 years, definitely.
When I presented, I had my laptop and I sat in the speaker room and prepared for the demos. So I had done the last pieces on the train to Gothenburg. Everything worked fine. In the speaker room, every query took 4 times as long as it should. And then it was a very demo intensive presentation. So my presentation would have been 1.5 hours instead of 60 minutes. And it turned out that when I had the power plugged in to the computer, that slowed down the CPU by a factor of 4.
Oh, wow.
I don't know why. I still don't know.
That's the opposite of what I would expect.
Yeah, I mean, me too. So when I did the demos, I had to unplug it and then plug it in again because the battery wouldn't last for 60 minutes. So when I went back to PowerPoint, I had to have it plugged in. Yeah, that's demos. But I mean, I survived that. So I'll survive anything after that, I guess.
That's right.
But
Adapt,
I'm going to
improvise,
release
overcome.
you, and I'm going to release everyone else, and I'm going to go back to getting paid or something. So thanks for coming, and let's talk about user group in the spring.
All right. Thank you, everybody. Have a great day.
And you. Bye.